Hello everyone and welcome to Handmade Hero Show, where we code a complete game live on stream. Now, one of the things that I get asked a lot, because we don't really cover it on Handmade Hero, one of the things I get asked a lot is, what do you do about source code control? Right? This is a very common question. What do you do about source code control? Do you use Git? Why don't you use Git to store the game? What's the plan there, right? And I haven't addressed it, and it's been, we've been doing this series for a long time. It's great. I love seeing everyone on the stream every week. And I just felt like at some point I was going to have to talk to you about how source code control should work, what you should do, that sort of thing. So the answer, everyone always says switch to Git whenever anyone's having trouble with source code control. It's absolutely true. Git's obviously the most powerful industry standard source code control out there. You've got to know how to use it. And personally, I just think people would be crazy to use anything else. Now, I understand the reticence that people have when using Git, okay? Because it was a hardcore professional grade thing. Linus Torvald, I'm sorry, I don't know the pronunciations as well as I should. When he was writing it, he wanted something for serious kernel development. So, this isn't something that's supposed to be super friendly or, like all fancy GUI or anything like that. It's a serious command line utility. So I understand it can be daunting. And so what I thought I'd do at the beginning of today's stream is I just wanted to give people a little introduction to, like, if you were on your own project, right, and you wanted to use source code control for it, and maybe you're a beginner, or maybe you're even intermediate, but you don't like taking the step to Git, something as hardcore as Git is a little bit scary for you. I just want to demystify you and show that it's really not. It shouldn't be something that's scary. So I prepared a little thing here. I made a temp Git directory, and I guess folks probably know. I did this hash function called meow hash. And I put it up on GitHub. Now, one of the things about GitHub that you might not know if you've only ever browsed on the web is actually you can use Git to interact directly with it. So if you go to any GitHub page, there's actually this clone or download button here, right? And in that window, there's a URL, and you can use that URL with the Git command line utility. So what I'm going to do is I'm going to show you how to get that this repository, my meow hash repository. I'm going to show you how to use Git to just quickly and easily just get it onto your machine. And if we encounter any problems along the way, I'll explain what they mean, and I'll show you how to get around them. Okay. So let's start with just the simple, the basic thing that you're going to want to do for any Git thing. Well, you know what? Let me start a little bit simpler. So if you just type Git, what you'll get is this kind of I don't want to be pedantic about it, but I say it's kind of useless. This is like a little help screen, and it only has the really basic commands on it, right? So these are like sort of the things that you would most commonly call, but anyone who really uses Git seriously knows that that's not, most of the things you're going to do are going to be more advanced than these commands. So these are really just, I would ignore this screen. What you want to do is focus on this down here. If you do git help -a, what that'll do is that'll list all the commands in Git, so not just the common ones. So if I do a git help -a, what you can see is that'll list all the commands that Git has in it in toto, right? Now, obviously, this listing can go on for a while because there's a lot of commands in Git. I mean, one of the things you have to understand about Git is it's industry standard now, so everyone kind of has, I don't know how to say it, but it's a lot like the Linux kernel, right? It started off as something small. It's based, both were made by Linus Torvalds, right? Started off small, then they become a lot more widespread, a lot more widely used. And so even though originally Git probably had only 100, 200, 300 commands, I think at last count there's something like 395,000 commands in Git, give or take. It depends, like, you can install modules to it. So this is just the baseline version, which has, I think, the 395K. Some installations can have 1.2, 1.3 million, but those commands, you don't necessarily need those for everyday use. This set of 395,000 are the ones that you would generally be using day to day, right? So I don't necessarily recommend doing the 1.2, 1.3 million root. That's just too many commands. And usually with a combination of some, 12, 13, 14 of those 395,000 base set commands, you can usually do what you want. And so a lot of times, if you look at the 1.2, 1.3, 1.4 million commands there, a lot of them are really just repackaging or like convenience versions of ones that you already have in the base, set that's the relatively concise, 400K set of commands. This listing can take a while. This is mostly Windows. It doesn't have a very efficient command line, as you know. Linux is obviously the place for command line, so this could go on for a while. So I'm just going to Control-C out of this. You don't really need to know all of these just yet. You will want to go through every single one of these commands eventually and really familiarize yourself with what each of them can do, because otherwise you're really not using Git to its fullest potential. So you do want to look at that list. Obviously, you can pipe it to more or something if you want to page through it one at a time. It only takes a couple weeks to get through that whole list. Obviously, I've done it before. It's pretty eye-opening because there's a lot of stuff in there that you wouldn't necessarily know about. So anyway, like I was saying, what we want to do is we want to start with a really basic Git command. It's called git clone. And what we're going to do is we're just going to take this URL here that's provided for as part of the GitHub repository. I'm just going to paste it in, and that's it, right? So again, people say that Git's scary. I don't know why they say that. It's not, that line right there will get you all the code. So you just hit return, and it'll do it, right? And then one of the things, this happens a lot to people, is they'll start using the repository right away after they do the clone. And I really don't recommend that. That's a source of a lot of problems for people, because typically what happens is if you clone a repository, all that's doing is moving the files onto your machine, right? But you still haven't done anything yet to make sure that those files are actually ready to be used, right? It's just a copy. It's not like a preparation. And so what you really want to do to make sure that everything is ready to go and you can actually start editing them is you want to use a command called git bless. And what git bless does is it takes the repository that you're in and it goes through every file and makes sure that in a spiritual sense, you're ready to edit that file without Git getting confused about what the file's supposed to do, right? So it's kind of like, the reason it's called bless is it's kind of like likening it to a religious ceremony. A lot of you out there are probably atheists or whatever. I don't want to imply there's like any real religion behind it. Anyone can use this command. It's non-denominational, but it's just evoking that sort of preparation, right? You don't want to do the animal sacrifice before you have the holy water or whatever, right? I don't know. I'm not familiar with how these things go. The same is true with Git. You want to make sure that the code is blessed before you modify it. Otherwise, when you go to do subsequent Git commands, who knows what could happen, right? I mean, you've more or less angered the gods at that point. So what you want to do is do a git bless, and you can just hit git bless return here. But I'm actually using a couple switches to git bless because in order to do git bless properly, I want to do a couple things. So I'm going to actually do a CPP reverse gardening on this one. And what that'll do is if you do CPP reverse gardening, so I should say first, before we get too far down that rat hole, I'm not going to cover like exactly what gardening is. But gardening involves essentially leaving space between the files. Normally what will happen, there's a default level of gardening. So when the files get placed in directories, there's a certain amount of empty space in between them. And that's if you want your code to go to seed right after, so that it will produce smaller versions of itself subsequently. If you want Git to do that as it builds hashes and stores backup versions of files, you want that empty space in there. Call me old-fashioned. I don't like to use a lot of space on the drive. So I use reverse gardening, and basically what you do is if you say the language that you're using, so CPP, and then you do reverse gardening, it'll say for all CPP files, take the space that you would have been using and actually reclaim that for other purposes. So I like to do a git bless with CPP reverse gardening to reduce the gardening, and then I also like to do a fallow rows heavy, right? which lets it know that on every other row that normally you would be saving for the next time, right, that you do a git bless, that these are going to be planted at the normal density that they would have been, right? So when you do that git planting. And then finally, what I like to do is I like to do this, you can do this two ways. You can do it the normal way, you can do it retrograde. So if you do it retrograde, it'll start at the furthest row for gardening, and it will go backwards. Whereas if you were going to do it the normal way, you wouldn't have any of that reverse motion, right? So I'm going to just do the git bless in this repository. As you can see, it's just going to go through, it's going to do some credentials checks. It's got to make room for the changes and that sort of thing, and branches and cache and stuff. Okay, so again, one of the things that happens in Git, it's definitely something that people, again, it puts people off. I don't think they should be scared about these sort of things. The error messages are a little bit cryptic, right? Errors in Git happen all the time, especially when you're working with a public repository, because remember, you're taking a repository that was made on someone else's machine, or even on your own machine. You know, if you have a multi-machine environment, maybe even you made it, but you made it on a different machine, you're moving it to a new machine, and so just the environments are a little bit different. So even if you're doing fairly standard stuff like git clone or git bless, sometimes you can get, basically you can get these errors that crop up. They're not a big deal. So I really encourage you to not get scared. Just read the error message, and usually what it says is the problem, right? So you can see here it says that unrevert mail would overwrite previous dget tree, right? And all that means is we did two git operations, right? So that first clone, in that first clone operation, there's a ton of stuff that has to happen. So one step of the clone operation is called get tree, right? And that's the thing that actually brings the remote repository onto your system, okay? That dget tree operation is just the reverse of that, because after you've gotten the tree, you need to like effectively undo that operation. You have to dget, right, that tree. Otherwise, you still have the tree in addition to the files, which you don't want, right? And so in this case, what it's basically saying is that I didn't set up any mailing system. Normally, whenever you do a git bless, it'll send mail to everyone in the blessings list, so that each one of those people knows that the source code has been blessed, right? It's a little bit like a papal edict or something, so that everyone knows within that sort of blessing circle who, everyone's been notified, so nobody thinks they have to bless it twice. Like, no, you don't want to waste time re-blessing code that's already been blessed. So what it's trying to do here, right, is it's trying to unrevert the mail changes that it thinks have happened, because normally when you do a git bless, you've been through a couple different mail cycles. And what it's realizing is that it's doing that right after a dget tree operation. And if you try to unrevert the mail list, the mail like blessing list or any other mail list, there's something like 75 different mail list types in Git. And this one in particular is talking about the blessing mailing list, because that's the one that we're doing, obviously. But you know, there's different ones for different commands. So if the unrevert mail operation would overwrite the situation that would have happened with the dget tree, where it moved it out of the way, right? That creates an error scenario. It's easy as pie to solve these. These are not hard. All you have to do is call the unrevert mail with a force command. So if you just say, look, I do want to unrevert mail, all right, because that's what it thinks to do. Just do -- ignore dget tree warnings, right? That will stop that. And you can see also there's a secondary note that says that the latest pro-ignore quilt, and it gives you that mail address, right? The one that was the mail it was on when it realized that it couldn't unrevert the mail because of the blessing dget tree that occurred, right? So what's going to happen here is you need to first ignore those dget tree warnings. And then what you want to do is look at the secondary list. And so in that case, quilting is a thing that happens in Git that I don't really, it's sort of like gardening. I don't want to go down the whole rat hole, but basically what it is it's for taking disparate pieces of the source tree and basically, you know, stitching them together, right? It's kind of a Git term of art. And so there's multiple different ways. There's a pre-ignore, there's a post-ignore, there's a pro-ignore, which is basically like, I have mine set to doing all of the like advanced feature levels. So if you have your Git configured to be doing the most advanced version of all the commands, you're gonna get pro-ignore messages. You can get amateur ignore messages if you have yours on the normal level. Also porcelain ignore messages. So pro-ignore quilt is just saying that the thing that was telling it that it didn't need to worry about quilt operations, right, on that particular mail was the thing that triggered the mail conflict, the unrevert mail conflict with the dget tree. So even though git unrevert mail -- ignore dget tree warnings probably would work here, I also want to give it a few quilt directives just so it knows that that's not a stopping factor, right? So I'm just going to go ahead and do a -- quilt always, which is basically saying, look, don't ignore the quilting, pro or otherwise. Just do the quilting you would normally do, regardless of what else happened, right? And then I'm also going to do a -- skip mail, and then I'm just going to type in this exact. You really want to make sure this exact. If you have, this is one of those things that people can really get in trouble. If you do a skip mail and then you put anything other than like a real mail hash in there, that can easily delete lots of existing work that you've done. So you want to make sure that you really like don't take a second when you do a skip mail directive and just make sure that you're typing that 100% accurate. Okay. So now we're going to do that unrevert mail, and we'll just, I think this will be fine now. Just sometimes it'll take, okay. So one of the other problems that you will see is that Git always is going to build a thing. There's essentially graphs underlying each Git operation. If you think about what's happening conceptually in a Git operation, what it is it builds sort of a set of nodes that are the possible states that the source tree could be in. And then what it's going to do is it's going to build a graph of the path through those states it wants to take, ideally, to solve to do the command that you're telling it to do, like in this case, the unrevert mail, right? So in this case, it built one of those graph subsets that it wanted to use, right? And when it traversed through it, when it was done, it was not able to remove that graph from the tree. That's the unsetup graph pass, is the thing that removes finished graph sections from the complete graph before the command is over. Because, again, Git really doesn't want you to lose work. I mean, it wants the work you lose to be your fault, I guess is the way to say it. Obviously, it loses work all the time. It wants that work to be verifiable. So if it can't set up all the graphs in the graph set, then it's not going to do it. This usually happens because the graph state got partially held over from a previous command. There's a thing called graph forwarding that happens automatically. It's basically there to save you time, but sometimes it actually creates errors, like in this case. So what you want to do here is pretty simple. It's just there's a git reset operation, and what that does is it says clear everything, right? Just clear all the states, don't hold over the graphs. But one of the things is, if you are in pro mode, so you probably haven't set your thing up for this, so you won't have to use these switches, but if you're in pro mode, graph reset by default, git reset by default won't do a full graph reset. It'll do what's called a hermeneutic graph reset, which is basically the same as a normal graph reset, but it won't get unrevert mail items, right? Because it assumes that the mail cluster and who you're sending mail to is not what you're trying to reset. You're just trying to set the file state. So what I need to do here is do no hermeneutic, right? So that way, when it does the reset, it's not going to do a hermeneutic graph reset. It's going to do a real full graph reset. And then the other thing you should always do here is force, right? Because otherwise, if you did the no hermeneutics, it might warn you that like there would have been a hermeneutic, right? I'm saying like, no, force, right? Okay, so it's doing it. All right, so I think we're basically done. I know this is making Git probably look harder than it really is, but this is just what happens, right? You saw there's no weirdness going on here, right? It's just when you're trying to sync a source tree for the first time, there's a lot of stuff that can go wrong. All right, so in here you can see we're having a particular problem with the try hash. Now, there's 3 or 4 levels of hashing in Git. You don't probably need to concern yourself too much with each individual one. There's the primary hashes, there's by hashes, and there's try hashes. Now, the primary hashes are hashes that actually come from your files. By hashes are when Git needs to look at 2 different files and combine their hashes into one hash. And then a try hash is when that by hash gets combined with 2 other by hashes. Now, this is a common mistake People often think a try-hash is a combination of 3 regular hashes. It's not. A try-hash is a combination of 3 bi-hashes. So it's really like a 6-way hash, but try-hash was just the term that sort of stuck. So we still call them try-hashes, and there is no real Git term for 3 hashes that were normal hashes combined together. A lot of people will call it a 3x hash, but you know, it's not baked into the program, so it's kind of just, that's vernacular at that point, right? Now again, this was happening because we tried to do resetting of that mail graph. Basically what it's saying is, when it was trying to record all of the hashes of those file graphs that it was producing, in order to undo the hermeneutic graph holdover from the revert mail. Now, obviously, I use IMAP for mail. That's where you're getting this in here, right? One of the things that you run into is Git divides the mail servers that it can talk to into a few different types, right? There's direct mail servers, there's indirect mail servers, there's semantic mail servers, and there's symbolic mail servers, right? And so symbolic mail servers are mail servers that don't actually exist. Like, they're mail servers that are effectively imaginary, right? And so what you're doing when you use a symbolic mail server is you're saying, let's pretend there's a mail server so that we can complete this operation. But when we're done, we're not actually going to send any mail, right? And so what's happening with the try-hash scribe index is it's trying to record what the try-hash was of that 6-way set of files, right? It's trying to put that into the global try-hash index so that it can do what's called a quad push, which is taking 4 try-hashes at a time. This is a performance thing. 4 try-hashes at a time to the symbolic server, right? It's basically like if you were to do each individual try-hash, there'd be a lot of dead space in the symbolic server packets. So a quad push takes 4 of those at a time and does them all at once, right? And so what you get out of a quad push is a lot more performance, but it's a lot riskier, right? In pro mode, I want to do quad pushes. I want to be faster all the time. I know how to handle these errors. This is not one I'm going to go into too much detail because, so I'm not going to explain how we're going to fix it. We're just going to fix it because I don't think you're going to see this one. Because if you don't have pro level settings engaged, you're never going to get a quad push error because it's just going to be doing single push the symbolic server to do those mail operations when mail is effectively sort of being emulated during that operation. So I'm just going to type in the line that fixes this, and you don't have to worry too much about this. All right, so once you've got essentially all of that taken care of, okay. So I actually wasn't expecting this. Okay, I'm really sorry about this. So Git divides things into 2 sections. It's called porcelain and plumbing. So porcelain, it's basically, think of a toilet, right? This is the analogy they use. In a toilet, you got the plumbing, which is the thing that actually does the work. And then you got a porcelain, which is the thing that you actually see as a human and interface with, right? So normally, because I'm in pro mode, I turn all the porcelain stuff off. But because I was trying to do a demo today, I enabled the porcelain stuff, which is basically user interface, like foofy stuff. It's stuff that you should turn off as soon as you can. You know, once you're familiar with the 395,000 base commands, you can turn off the porcelain nonsense. It's not useful. But I had turned it on, and so you can see once we were working with that scribe index, when it tried to do the try revert based on the command that I gave it, probably because I said exacerbate shim, but again, I don't really want to go into what that does, that caused a conflict with what it would normally do. The reverse of a quad push is a quad read, right? You can see it happening down in here. So the quad read that was trying to get back from the symbolic server what the pretty message was to display on this command, that failed. And it failed because obviously I didn't go into how you set up a Git symbolic server. Obviously I did that beforehand. That's kind of a more advanced topic. I would just let one of the default installers do it for you. But when I set mine up, right, I set it up a pro level. I didn't install the porcelain modules. It doesn't even have those messages. So you're gonna get those problems cropping up. So all I'm gonna do is I'm gonna run the exact same command again. I'm gonna say no porcelain, and I'm gonna say unprint errors. That way it won't think it needs to get those messages, right? Let's give that one more shot. I think this should be fine. I think we're good here. All right. So one of the problems that you will see when you're trying to fix a quilting problem like that, because you noticed beforehand, right? I don't know if you remember when we were executing this command up here. Let's just go back up here. I told it to do quilt always. So what you're really supposed to do in that particular command, right? If you're doing an actual unrevert mail here, the safe way to do an unrevert mail is to actually open up a text editor and to list. What you want to do is you want to list all of the things that should actually be quilted, which is typically not all of them. And so one of the problems is if you have something that's formatted in a way such that it can't be quilted, then a later command will eventually try to verify that quilt. Again, using the performance mode here, it's trying to do them four at a time. That's not the problem here. Even the single verify quilt would have failed. When it tries to verify a quilt on something that was not formatted for quilting, which of course I accidentally induced it to do by just saying quilt always, that's gonna fail, right? Again, we can run the same command, we just have to add one more switch, which is that like, if you ignore quilt errors, right, and requilt unquilted formats, that should take care of any, like, quilting is not an essential feature, so basically it's just saying, look, if there was a quilting error, don't worry about it, just requilt any of those quilt sections that were wrong, right? So crossing our fingers here, this hopefully will be the one that actually finally gets the repository into a good state. Perfect, right? So now if I just do a directory, you can see there's meow hash. I go in there, right? There it is. It's all ready for me and totally set to go. So I hope that gave you some appreciation for how simple it is to just get started on Git, right? I mean, we had some errors and some of them were a little bit complicated, you know, I agree, but hopefully you could see from my explanations of them, once you pull back the curtain and just see what's actually going on, right? Once you know about, you know, quilts and hermeneutic graphs and all those sorts of things, it becomes actually very simple to navigate your way through it. You don't have to be scared, right? Sometimes it deletes all of your changes or all of your data. That's okay. That's just an excuse to start over. A lot of times, you know, writing code fresh is better, right? And so I think a lot of the criticism leveled at Git that it's too complicated, that it loses all your files, those sorts of things, I don't really think that that's true, right? That's people blowing things out of proportion, not learning how to use the software. You know, these are people who probably only know how to use 6, 7, 8,000 out of the 395,000 commands in Git, not to mention the switches, which they probably just don't even know about, right, a lot of the times. So I really do think it's worth your time to just, you know, forget that stuff and say, I'm going to commit some time to learning Git. It's not that hard. And I think everyone out there who follows Handmade Hero, you can do it. And the rewards that you will reap from learning this are immense, right? Like I said, you know, you can go from a situation where you know, were doing work every day with files and had to, you know, use something like, I don't know, like SVN or something like that, that, you know, doesn't lose your files and can store binary data and is relatively easy to use. You can go to something like Git that's way more powerful and only sometimes loses your files. And, you know, it probably takes only 2 or 3 hours a day of work in Git to copy things from like one machine to another and stuff like that, which is well worth the time investment. So I highly recommend it. I think everyone should, in fact, switch to Git. And hopefully this tutorial is enough to like whet your appetite. There's a lot of great tutorials out there, so, you know, seek them out. And before we get started on actually programming today, let me just go and ask, does the stream have any questions? Did all of that make sense? I hope I was kind of talking a lot there. Did anyone have any questions for me about what we covered just there on Git? Anything that you want me to show you in addition to that? So Reductum said, could you go over the git soil archive command? I've had a really hard time understanding the docs on it. Okay. Okay. Yeah. I could definitely do that. Let me just fire that up here. Okay. Don't worry about that error message. It's not important. Okay. Could you go to the git soil archive command? I totally can. I staged this repository for it. So the git soil archive command, that's this command. What the git soil archive command does is it's basically saying, much like when you see that, remember I was talking about that gardening, the reverse gardening. So normally when you do an archive, what's going to happen is it's going to get rid of that spacing, right? That gardening. If you had gardening in the repository normally, when you do the archive, it's going to get rid of that, right? And so the problem with that, when you do an archive, is when the person decompresses the archive on the other end, they lose all the gardening. So git soil archive is something you do to an archive ahead of time in order to make sure that when you put a Git repository into the archive, it still has that padding, right? So in our case, what we would do is we'd say like git soil archive, like, you know, like mowhash.tgz or any other archive type that you want. They're all bit in. I think Git has support for 73 different archive formats. So you know, you can use pretty much everything that you want. So you do git soil archive, the archive to use, and then you want to do like probably gardening optimal, because you want it to look at how much should be put in. So how much, you have a certain amount of soil, right? You can't just make it out of thin air. So you gotta figure out how much soil do you want to leave in the ground, right, in the repository, and how much soil you want to put into the actual archive itself for the receiving repository, or garden as it were, right? Gardening optimal will compute that, but one of the problems with, so, all right, I don't want to spend too much time on Git today, so I'm sorry if this is a little bit truncated of an explanation, but optimal gardening is a problem that computer science hasn't been able to solve. It's NP complete. No one really knows to what extent you can do literally optimal gardening. So when you supply when you pass an optimal gardening switch to Git, you need to tell it, in addition to the optimal gardening, something called a P parameter. And the P parameter is a thing that the optimal gardening heuristic inside Git will use to know when it has gotten the gardening optimal enough, right? Because actually ensuring fully optimal gardening is not always possible. So you want to supply an optimal gardening parameter. I usually use 0.07894513312, which is also what Linus Torvalds recommends. I think he's right on this. There's competing camps on whether you should use this constant, or there's other constants out there that are sort of banned about. I would stick with this one. So if you pass an optimal gardening parameter to git soil archive, and then you probably also want to do, so normally when you do a git soil archive, what it will do is it'll soil the archive and then it will re-soil itself, right? In other words, the local repository. So what you want to do is do not re-soil yourself and you can also do, alternately you can do like do not soil yourself. But do not soil yourself will take effect for all future Git invocations. It'll actually update the config. So what you want to do is do not re-soil yourself, so that it knows that only during this particular command, right, that should do that. So hopefully that makes some sense. Does anyone have, I don't know, it's like, while that's running, let's see here. What if atomization fails? So atomization failures are not a huge deal. You can just run git pre-atomize with -- ignore atomization failures, and that should take care of most of that. If it doesn't, then I don't know. Oh, okay. So the xref server on this machine is kind of borked, so I would... don't worry, ignore that. That won't happen. This command is fine for you to use. That's has to do with the Express server set up on this machine, which never worked right, so it doesn't matter. Let me see here if we got anyone's. Let's see here. I've heard the sequel says I heard Knuth recently proved gardening had a probabilistic polynomial time algorithm. It just has huge coefficients. So if that's true, that could be pretty huge for Git. I don't know to what extent I believe that. I mean, if Knuth says it's probably right, I mean, he's obviously a godfather of computing. So, you know, I don't want to challenge his authority on that. But like I said, I don't know anything about that. I haven't seen that news. Longbolian says, I'm still skeptical. Will this affect the arrangement of my garden gnomes? Rearranging them is not really something that I'm able to do as they are permanently fixed in place. Okay, so I guess what I'd say about that is statuary is a very advanced feature in Git gardening, and I don't want to mislead you by suggesting that you can just start rearranging the Git gardening gnomes to anywhere inside the repository and not have huge potential pitfalls awaiting you. You can. I just want to make it clear that there is no such thing as a fixed Git garden gnome. All gnomes are movable. You just have to use the assume mutable gnomes flag on whatever command you would have used. So for example, if you were going to use a git bless by gnome command, right? Which is to say you wanted to use those garden gnomes as the thing that was actually going to do the repository blessing. If that would have given you an error that's like error gnomes are fixed in this case, right? What you can do is just say assume mutable gnomes. A lot of people don't know about that switch, but it totally works. If you do that, it will never give you a fixed gnome error. Now, this probably won't work because I didn't actually set up any gnomes in this particular garden repository, but that's, I just want to make it clear that's, so again, pretty much all the problems we're getting are with the IMAP server, the mail servers, right? So I really don't want you to ProCP insta column is basically when you are trying to copy column from one to the other in pro mode, and you want to do it without the normal verify step. You can see that it's having a problem with the fact that I have more than one IMAP server listed. That's probably just something happened when I did the config to put in the amateur porcelain stuff. The same thing that screwed up the XREF server probably screwed this up, right? It's, again, fixable. You don't even need to worry about that error. Can you explain the tricycle entropy option? So, I mean, I guess what I'd say about tricycle entropy is unless you're working on, like, literally government-grade encryption standards, tricycle entropy is really not necessary. So bicycle entropy is way, way faster. It's about 17 times faster because tricycle entropy is going to do tons of iterations. So I would just say use minus bicycle entropy because that's going to give you a way more efficient entropy operation, whichever one you were doing, with really no downgrade in security unless you're expecting like state level attackers, basically, right? Plus, if you're going to do tricycle entropy, you would also have to do an minus Mossad on it as well, just to make sure that it uses Mossad approved enclosures, because only Mossad strength enclosures are resistant to the kind of attacks that tricycle entropy is designed to prevent. So again, you're in state actor territory there, and you're going to be wanting to use, if not Mossad level enclosures, use Five Eyes enclosures, or something that's state level encryption quality, because you're basically saying I want state level encryption because I expect state level actor threat profiles, right? All right. I don't want to spend too much more time on Git. Hopefully that gave everyone a good understanding of how it all works and how to get started with it. Let's go ahead and go on with the series. All right. So, if you remember, last week we sort of got ourselves to a pretty good stopping point. Let me go ahead and open up the game here. I'm going to launch Fored, and then I'm going to go ahead and try to remember what all the keys are here. Okay. I really need to update to the new forecoder on this machine, but Alan and I have kind of been going back and forth on some changes, and so I've been in a situation where I have one meow hash that I'm using on the other machine. I'm sorry, not one meow hash. One forecoder I'm using on the other machine and one forecoder I'm using here, which is not a good idea because I made a bunch of changes. So yeah, that's a bit of an issue. But let me go ahead and do a quick build, and then I'm going to go ahead and do an MS Dev here. And I just want to give a quick recap. And okay, I don't know what this is telling me to do. What? Okay. So what is happening here? I don't really want to know. So I guess we won't be using Visual Studio. All right. So I guess what we've learned is Visual Studio no longer wants to be used on Handmade Hero. And you know what? That's fine with me. I don't like all of its garbage anyway. So I guess today is the day we switch to Remedy, and we're just going to have to hope that George has our back on this one. All right, so let me go ahead and switch debuggers real quick. This was not planned, by the way. I didn't think that, you know, silly me, and I realize that I'm just crazy here. You know, you would have thought that Microsoft would want their product to look good on a stream and wouldn't make it randomly deauthorize itself and then produce an error message in a JavaScript interpreter window. But, you know, that's just the kind of quality that Microsoft delivers these days. So I'm going to go ahead and go in here, and I'm going to download Remedy, which I bought. And I'm going to download that, and we're just going to use that to debug from now on. And it's not really done yet. It's only version 0.1. But hey, at least it will run, which is more than I can say for Visual Studio. All right. So, let's see here. Here's Remedy on the thumb drive. I will put that down here somewhere. Let's make a directory for it, shall we? So what I'm doing here is I'm just going to use the in-development debugger that George Menhorn is working on. X13 Pixels, if you see him in the chat, that's who we're talking about here. And I'm going to go ahead and unpack his debugger into this directory. There it is. And I think that unless there's an apps remedy. Oh, there is. Okay, never mind. We already had a directory for it, so I'm going to put it in there. There we go. Okay. And so in this remedy directory, what you can see here, I don't need this stuff anymore, I don't think. So what you can see here is I've got the only two files in the remedy distribution. So refreshing. Just, it's an executable that you run. And if you run it, you know, it comes up instantly. I know Microsoft has long forgotten that there is such a thing as an executable that you can run by itself. Like, I don't know that there are people at Microsoft who still know that an executable can run by itself without 30,000 files in a SQL Server install. But it turns out that's actually true. And .NET. So Remedy, if you run it, it's pretty similar to Visual Studio in terms of the way it looks. The only real difference is, you know, you don't have project configuration windows because it doesn't do builds, right? And so what you have is this little thing here where you can say what you want to run. And so I'm just going to go ahead and load up Handmade Hero into that, and we'll just go from there. So I want to run Win32 Handmade, right? We don't have any command arguments at the moment, but the working directory is whandmade. There we go. And I'm going to save this into our debug directory under Win32 Handmade. I think we already did this when we tested it out. And so what you can see here is it works pretty similar. If I hit F5, I can... Oh, so I should say where you can get this too if you want to follow along at home. You can go here. So remedybg.itch.io/remedybg that. Or actually, can you just do this? Yeah. So you can just do that. And this right here, you can buy it. Looks like it's $10. And you can get exactly what it is. It's still in development. Like I said, it's only version 0.1. So keep that in mind. Don't expect it to be completely polished. Don't expect there to be no bugs. But it does work. I've tried it a bunch. I think the only thing that I've noticed lately, bug-wise, is it looks like it has some trouble displaying things that are compound structures passed as parameters. It seemed to be having trouble with that. So like if you have a struct that's a parameter to a function, it seemed to be having trouble displaying those properly. Like it couldn't figure out where they were or something. So there's a couple bugs like that. I haven't reported all of them to George yet, so I'm getting to that. I do want to switch this eventually, and it looks like maybe our hand's going to be forced there because Microsoft just pooped out on us. So anyway, if I hit F5, it runs as normal. Here's our game running, right, and everything's fine. And in here, you can do the same sort of stuff you would normally do in Visual Studio. So, it's got like windows that are dockable, and the windows are similar, like, right, there's a registers window and a memory window and everything, right? And so we can recreate essentially what we had. So, I normally put like the watch window up here, right? And we've typically got like the call stack and stuff like that. I don't know what else we used to put down at the bottom exactly. So I'm not sure. So I'm going to pull these up here because I don't really remember how this stuff worked, and I'm going to dock them sort of separately just so I understand exactly how it used to go. I'm just trying to remember. So I know we used to put the call stack, just trying to recreate it. I know we used to put the call stack kind of down, and probably the breakpoints sort of down in here. So like the breakpoints window, the breakpoints window, I won't probably be able to get to that without shrinking these down, huh? Too many windows on the screen. Sorry, I just want to take a second to set this up so it's basically the same. I think most people probably will be fine with it. Probably won't be too different for now. Okay. There we go. All right, so I need to put the breakpoints window down here. I think this is how we used to have it. So the call stack probably would have gone there, right? So probably have these two. The output window usually goes like down here. Oops, that's not where I wanted that. Registers probably went up here. Maybe, I don't know. Let's say that it did. I'm gonna put memory down here for now because I'm not sure where it went. Modules can go up here because that's rarely used. Threads is more common, so I may want threads to kind of be here all the time. Like it's just a little bit of like a thing I can do here. And then output, I'm just going to put down at the bottom, or try to. Where's my source window? Well, you know what, I'll step in, that'll get me one, right? Or break, rather. Break. There we go. Oh, and disassembly. So the disassembly will go down here as well, I think. So I'm going to put the output and the disassembly there. Let me step up to a source window so we can get that in place. And then hopefully we're good to go. We'll see. So this is in Handmade Hero here. So there's our source window. I'm going to put the output window down in here and the disassembly down there. So that's how I think I'm going to run this for now. And we'll just see how it goes from here on out, because I have no idea how it will go from here on out. So, all right. So let's go ahead and save this session. Save. And in theory, I think, hopefully, now, I don't know if we made a remedy batch file. We did. So when you load it up again, I think I should just be able to do this, and we should be good to go. So we shouldn't have to fuss with the windows anymore, and I think we're good. Okay. All right, so Visual Studio replaced, not because I wanted to, but because it literally decided it didn't want to be used anymore, which is great. Back to our story. So what our situation is currently is, we did our Sprite testing stuff and we're pretty happy with it. There's just one thing that I think I want to tackle here, and it's something that we kind of did late at the end of the previous stream. And what that is if you look at what happens to our hero here, all of the sprite sorting actually worked out quite well, except for one thing that I did, and I want to fix it. So you'll notice it sorts really well into everything now. Like, it's very, very good. Ignore the glove at the moment because we didn't do any programming for the glove. It's just kind of sitting there now. And so it will not keep itself in a good place for sorting. It's completely busted. But if you look at what we're actually doing here, right, you can see that the glove should be sorted down a little lower. We can fix that anytime we want, but I just don't care about the glove at the moment. What you can see about this is it's doing really good to let us do full 3D with our stuff. It sorts things in really nicely and yet still presents them in a nice 2D way. I'm really happy with how we did that. It took us a bunch of work to figure out how we should do that properly. I think we did a great job. There's just one issue. Do you see how we're clipping into the ground there? So we already have solved this issue, meaning we know how to not clip it into the ground. We effectively disabled the thing that would have prevented it from getting clipped into the ground. And the reason that we did that was because we didn't want freely rotating objects to change their sort distance too much, right? Because what's actually happening there, and you can kind of see what's going on, right, is we're shearing. Do you see how we're shearing? That axis is it's sheared, right? And that shearing is creating something that extends down into the plane. We had previously explicitly solved for where to put this point so that it wouldn't extend down to the plane. But the problem is we locked that distance. So we don't let it increase that as the user pushes the shear or the rotation. And that's what's causing the problem. So we have to make a decision here about what we want to do. When we create those shearing effects, because we are fundamentally basing the character at a particular location in the world that is not where it has to shim the sprites to, if we do fix the location, we will interpenetrate. Now, we could choose to hover the character a little bit to prevent that. That doesn't seem like a great solution. We could choose to not fix the distance. And that, to me, sounds better. Why does it sound better? Well, the reason we fixed the distance was to prevent spinning things or other stuff like that from pulsing, right? From going in and out, in and out. That is a very small subset of the things that will actually happen in the game. And so what I'm thinking is we probably want the default behavior to be the adjustment that we were doing before. And then if we do have to handle something that's like continuously spinning, maybe that's just a flag we put in there, right? Maybe that's just something that we handle specially. So I want to show you that code, and I want to see what we can do about it. So if you remember how this works, inside the entity set, wow, I can't see anything. It's too bright outside. Hold on a second. Yeah, man, that's bright. Too much sun. Thought Seattle wasn't supposed to have sun. So if you take a look at what happens during entity rendering, what you can see here is we do a bunch of work to figure out where the sprite should be placed, and you can actually see that happening when it actually places the minimum P. So you can see this operation occurring here. It says, look, how high is the sprite, right? Like how high up is the sprite? And what is the camera Z axis? Right, the Z, not the camera Z axis. What is the Z component of the camera Z axis, right? So which, for every step we take towards the camera, how high up would be going in Z? And then what we're doing is taking the placement that we would have used and we're sliding it forward in, along the camera's z-axis for however long that would be. So however much we would actually need it to be for that height offset, right? And so what that's doing is that's lifting us up so that the base of our cells, I guess, will not go through whatever the point was that we started on, if that makes sense. And so when we do sprite values for upright, which is the call that gives us this information, here it is, right there. When we do this, what you can see is that z displacement is a constant value, right? It's not taking into account the actual z displacement based on the rotated axes, right? It's just kind of doing a constant value that will not depend on anything in particular, I believe. Or am I wrong about that? Well, actually, what's our y-axis h? So yeah. The fact that it's using the h there is why it's constant, right? So this is the y-axis we're actually using, which includes the user's twist, right? It includes the rotation that the user is sort of enforcing there. And then this y-axis h is actually, that's what's telling us, hey, here's the camera version, the thing that's just constant in camera space. So this is never going to change, no matter how the sprite rotates, right? Only different camera positioning will ever change the y-axis h value. And so that's why, in this case, this thing doesn't actually vary. It's because of that, right? Of that z value. So in our case, if we wanted to figure out what that displacement's going to be, you can see us here, like we've got the align py, that's the amount of shift there is off of the baseline. You can see the world dim y, and that's that height there, so that's how much we're going to move. And then this is basically saying, well, that's the axis that we were going to move along in z, right? And the problem that we have is that it doesn't correspond to this. It doesn't actually correspond to the value that we're getting here, right? And so if we change this to be using the actual y-axis that includes the shearing, I would suspect we would get a result that has less of the problem, right? But I don't actually know. So it doesn't look like we actually get much of an improvement there. Which is a little weird. Oh, so that already has the world dim y in it. So this should... I'm going to save this computation, the one we had before. And I'm going to remove that and this, just to see what happens if we just use the real axis we were actually going to render along, right? And so that does in fact solve the problem, which is what I was expecting to have happen. I forgot that it would double count the length, but once we remove double counting of the length, we're good. And what you can see there is now we always solve correctly for the that interpenetration, and it's good, right? And so the only real problem we will ever have with this, because I can now just go through everywhere and I think everything will just be fine, right? So if I just go through any particular place that I want to now, exploring in the world, I shouldn't ever really have any problems with that, right? And in some sense, in some cases, like here, well, it's a little bit hard to see, but you can see that actually the arc of the character incorrectly goes through geometry. So we will get some interpenetration till we fix these arcs to properly go up and down, like to always hop as large a hop as necessary. But even there, it's actually not noticeable particularly much. There's a little bit of interpenetration right there. So just a larger arc will fix that problem, if that makes sense. But, you know, otherwise, this just solves the problem. So I think what we want to do, at least for now, is say maybe that's just how we compute this. And then we will do some sort of, if we have something rotating around that's pulsing too much, we'll just fix that as necessary, right? I think that should probably be sufficient for now. And then if we need to come up with something even more creative with how we project it, we can cross that bridge once we actually have an example of something that doesn't work, right? That seems to me to be the most sane solution to the problem. At least that's what I would say. Seems like a good plan. I don't know. If other people have a better idea, we can also try something else. But that seems to me to be fine. I'll be honest with you. I don't remember. Oh, right. The reason that there's 2 exits to things is for placing items room. So this is like an item room or something. So all right. So anyway, I think all this is working great. I'm pretty happy with how it looks. So I think we can now move on to other problems. One thing that we do have right now, you can see when we introduce the hopping in actual Z, do you see how we're getting flashing of these bricks now? The reason for that is the height of the character, not the camera, is what's determining that value. And so I think what we probably want to do there is actually let the camera's resolved position be the thing that's actually going to do that clamping. Like where the camera would like to stay, because the camera is like ignoring that Z, and we want the fading of blocks, like, which is just our alpha Z range. Ooh, we had a what's wrong here? Total weight 0. Oh, this is a lighting bug. I don't really care about that because we have to redo the lighting anyway. Point being, we want ideally not to change the Z bounds for that information unless we actually detect that the camera would be moving, right? So if we're going to leave the camera at 1 Z level, we don't really want we don't want to include things like that bounce if the entity itself is just not really going to be moving its general Z value. So we want a notion of what the ground level point for this thing is actually going to be. I think we need some way of making sure that the camera understands that. And I'm not sure the best way to do that, but I think that's one thing that we want to put on our list. If that makes sense. So just looking at what I think we should probably be working on now, I'm going to go ahead and say that, yeah, it's kind of a toss-up. I think what we probably want to do is finish up the asset packing and stuff for sounds and things like that, so we can call that system done. So I think we may want to move on to that. And then I think we want to finalize our rendering path, so fix up the lighting so that we're happy with it, because there's only the sort of test lighting in there now, which you can see the barrier moving on, right? So we want something that's going to be really nice and clean for that as we go forward. And I have some ideas about how to fix that, actually, so I think it might not be as bad as it could be. But I also did want to point out that I do think we made the right decision doing some pretty good lighting in there, because the difference between, if you look at how nice it looks with the lighting in there, it just looks much better, right? So I feel like we really made the right decision having some realistic lighting, because it just provides so much character. I mean, look at what it looks like when you don't have lighting, right? That's what things look like. And there's just no subtlety to it, right? So I think we definitely want the good lighting in there. We just want to hack it a little bit more than we're hacking it right now. So do a worse approximation, basically, not so much raycasting. Because right now it's a little bit too accurate, so we just can't do it at the speeds that we would want. Unless maybe we start using GPU nonsense or stuff like that, but I don't really want to go down that route. So I really do think we made the right decision putting some nice lighting in there. I just think we now need to go in and maybe tone it down a bit, make it a little bit more semantic and a little bit less realistic, so that we can still have just a really nice, consistent performance profile for the game, even if you don't have the world's beefiest system. And then, yeah, so I think we want to kind of follow that path. For now, I'm going to leave this like this, and I'm going to put to do in here that says we need to assess this calculation and perhaps introduce a selectable alternate version for the scenario where we have spinning entities. Right. Because I really do think we're going to have a little bit of a problem with spinning entities, so I'm pretty sure we should go back and look at those a little bit more carefully when the time comes. All right, so what I want to do now is start pushing, again, on the asset side of things. We could do some cleanup. We should get wave files in there. We have some test wave files. Right now we're not doing anything with them. So if we look inside Handmade, right now we've got sort of this data directory. And I think, yeah, you can see in here, and I don't know if you can even hear these. Let me see right now. Let me, on this machine, tab over to the OBS window. I don't actually know what will happen if I play a sound on here. So I'm not hearing it, for starters. So I can't hear it either. It's not just you. It says USB audio device for speakers. Why does it say that? I just want... There it is. Can you guys hear that? Everyone got that? Perfect. Okay. So if we want to put some of these in there, right? I don't know what these all are. Got some bloops. All right. So we've got some stupid sounds here that we can just use for testing. And so what I want to do, because we don't have the sound importing put into this path, like we did sound importing before, but we don't have it part of the nice like dynamic loading system and all that stuff that that we ended up doing for the art assets and stuff. So if we want to start making this work the same way as everything else is working, what I'm going to do is I'm going to grab that data and I'm going to put it into the sources directory as just a test. So into that like base game directory where we've got the art, music, sound, we sort of set it up for these things to exist in here, right? And so what I'm going to do is I'm going to take the music test and then I'm going to put the other things into sound. And so we've got music in one and we've got sound in another. And what I want to do is I want to make the parser that parses the tag files know how to load music and sound like it knows how to load everything else. So if we look at the asset directory, right, all I'm going to do is just add the parser for it today, and then tomorrow we'll merge in our, because this is really just going to be an exercise mostly in cut and paste, because we did all the work for this already. We just need to merge it into the game so it's something that can be run automatically, right? So if I go into the, I'm sorry, I actually want there's an import there's an import file now. So if I go into the import file, what you can see is inside our synchronized asset file changes, right? We go through and we read each one of these HT files, And those HHT files, as you'll recall, are in the tags directory. And I don't know what these are. I guess, excuse me. So I guess this is where Windows decided to put our temp files when we were doing the temp file stuff. Oh, right, because it will rewrite them in that directory. And I guess it just didn't delete them. So that's fine. I'll delete them for you. I thought the whole point of opening as a temp file was that it would delete. Well, we probably don't pass the right flags for that. Maybe? I'm not sure. We can look at that separately. Point being, if I go in and open up the base game asset file, you know, in here we've got like all this stuff, right? There's like heads and bodies and blocks and blah, 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 right? What I want to be able to do is add sound stuff in here. So, you know, if you take a look at what's going on in the Handmade sources directory, you can see that inside base game, there's that music and there's musictest.wav. And so what I would like to do is just say, well, I guess we just have music and it's musictest.wav, right? And, you know, it should have tags just like everything else has tags. So like, you know, in the same way that we tag this stuff with information that tells the game what it is, we can do the same here. So we could say like tags, I don't know, maybe this is like intro music or something. And I don't know, so in our tags file, we don't actually have anything for tagging music at the moment, I don't think. You can see here that we just have like a bunch of tags that we use for stuff. And so if I wanted to do some tags for this, I could just say, let's just make a tag for like the title screen, I guess. I think also if I'm honest about it, actually, I suppose this should be in the intro tags file. So you know how we have the intro cutscene. So you can see here, like this stuff is labeled with like these shot tags and all this stuff, right? Seems like maybe I should just call this the title screen music. So in here, what I'm going to do is say, look, there's a music test in here, and by the way, the author on that is not Anna Repberg. Actually, I guess the author on this is Casey Muratori. And also, this description is wrong. So all I really want to do here is have some tags for the music test, which we'll say is for the intro cutscene. One of the interesting things about this, you can see here we have like shot index, layer index, and what we did for the title screen is we had like a thing here. I'm kind of interested in saying, look, maybe we just say there's a tag for the intro cutscene, and maybe we say there's a tag for the title screen. Oh God. What just happened? I've gone into some kind of screenshot mode. Okay. It's fine. So that way I can tag these things more properly. Like right now, they're not tagged with that. And so like what I'd like to do is say, look, there's shot index 1, layer index 1 for the title screen. So I'm just going to say this is the title screen, like this. And then these I'm going to say that these are the intro cutscene. And that way I can load these by what they actually were. And if I added another cutscene, I would just load that as a separate cutscene, right? So I think that's what I would rather do than the way we were doing this before, where it's just there's no extra tagging per thing. That just feels a little bit better to me. I don't know. Like I said, it's experimental, so who knows, but that's just what seems like the best idea. So here I could just say that, look, this is the music for the title screen. And we don't really need, I don't think, anything else because it's not like the title screen needs more than one piece of music, probably. So I feel like that is fine. So in here where we do those tags, I'm just going to put our own tag in here where we say that intro cutscene. Again, doing the magic of C where you have to do everything yourself. Title screen. So these will both be parsable now. And so now when we come through here, it will see this and it can tag it with title screen. Of course, it doesn't know what a music directive is. So if we actually tried to run this, it should fail and give us an error that it doesn't understand the music directive. So we have to add that directive. And so we'll do that. And then the other thing that we need is we need a directive for sounds. So like in the base game, we need some way of having sounds in here. Like we need to do this sort of thing. And those also need to be tagged. At the moment, we don't actually know what we would tag any of these things because we don't actually have any real use for them. So yeah, like who knows? But what we would like to do here is, let me just see, do we have any tagging for this at all? Blah, 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 blah. No, we don't. So, you know, I'll add some tags for it because why not, I guess. We've got a bloop, a crack, a drop, a slide, and a pup. So, sure, I don't know. Let's add them. So we're going to add bloops, cracks, drops, glides, and pups. Don't ask me why. And then we're going to put in these files. So we have bloop00.wav, and we know that that's going to be tagged thusly. And we know that it's essentially like a variant. So I don't think we have the concept of variant at the moment. And I do think that's probably something we want. So we probably want also like this. So we can essentially say, look, this is variant 0 of this thing. That way, when we do multiple of them, we can just say, hey, there's like several of these imported in here that we want. And so they can just be variants off the same thing that you query, and the game doesn't have to know about that like at all, right? So that gives us a way to, you know, easily put in 0 through 0, 1, 2, 3, 4 variants of those bloops. And then, you know, I can do the same thing here for the crack. And this one doesn't really need a variant because at the moment, anyway, we don't have multiple variants of that. The same with drop and glide. So if I do a drop and a glide, then we just have poop left. And that will have variants. So that has a variant 0 and 1. So I think that's everything for at least the import listing. And so now we just need to actually teach the parser like what those mean, because we don't actually have any sort of, we have nothing in there that talks about music or sound at all in terms of the ingest. So we kind of need some way of having that, you know, be understood by the parser. So, all right, just putting that in there. We've got drop, glide, and pup. Oops. And then we've got the variant. So that's everything that we actually need to recognize what's in the files. But we don't actually have any way of looking at those more expansive keywords, right? So inside Handmade import, we've got to start handling those directives properly. So what you can see in here is, you know, there's a parse top level block in directive up here. And we're going to run into some issues, right? This is going to be more complicated. And that's why I say we're going to do it tomorrow. All I want to do is kind of get the infrastructure in place today. So we don't have a whole lot of time left. I think we've only got about 30 minutes or so. How much time do we have? So we started at 12:15. So we've got, I don't know, yeah, 30 minutes, 35 minutes, something like that. So what I want to do is make sure that this parser can parse through them, and it's going to require some work. The reason is because this routine, as you can see here, it presupposes that you've got an art block. So you can see in here when it comes through and says is default, you can see how it starts to, try to figure out where to get this particular data from. It's literally starting like right off the bat to call things like parse pieces, but that's not what you would want to do if the thing is an audio file. So we kind of need, not necessarily two entire paths, but we at least need this function to be aware of the fact that it's not always getting that. So this subdir art, for example, would need to be able to split into a couple of different ways. So one way we could do it is like is music, is sound, for example, and these are like that, right? And so we would know now which one of these we're actually dealing with, and when we come down here to look at those, we could also do something that looks like this, where something like is art is comprised of like the knot of all of these, right? So if we know we're not looking at a default or music or sound, then we know that it is the normal thing that we expect to see most of the time in terms of our block types, because most of our block types are artwork. All right, so coming through here, we would say, all right, the subdir, in this case, we can actually determine up here in sort of a more speculative way and just say, look, if it's music, we'll change it. If it's sound, we'll change it, right? We could even do it this way, right? So we say, all right, it's the music directory if it's music. It's the sound directory if it's sound. And it's the art, it's the art directory if it's art. So now we know like which subdirectory we're going to look in to find the asset that's named based on the block type. And then in here, when we actually try to load the file, this match operation is probably still fine because we probably still do want to remember the asset source file stuff effectively the same way as we were remembering it before. The only difference now is that parse pieces, which would normally go in and do all kinds of crazy stuff in terms of grid importing, doesn't actually need to be there. And the import type that we have can basically be handled a separate way. So another way to do it, and I guess maybe we could have done it this way originally, maybe I should push the import type up and have that record specifically which kind of import type we're doing for art or music. I don't know that I really want to do that though, because like if you look at what's going to happen to some of this stuff, like with the grid points here, and align points and stuff, this is really stuff that's only going to happen behind an isArt call. And so I kind of just want isArt to bracket those things and force the sort of extra stuff that happens with art to not happen, right? And so I'm just going to do an isArt call around these and keep them from interfering most of the time, right? The rest of this stuff, like author, description, name, tags, and that stuff are all fine. The alignment stuff, we can still allow it to happen, probably, although we could also just error out here. We could say, like, look, if it's not art, that's an error, right? So we can say, hey, you're not allowed to put alignment points on an audio asset. Now, that's not the same as saying we might not have something like an alignment point on an audio asset. Like maybe in the future we want to label a particular sample offset. You know what I mean? And we could do that, but I'm not going to do that prophylactically. Like I'm going to wait till we actually have to do something along those lines before I'm going to really look into that, because I don't want to do a bunch of work for something there that we never use. So I'd like to at least have some indication that we need alignment points in audio before I'm going to actually add alignment points in audio. But at the very least, what we do know is that if we were going to process them, they certainly wouldn't be running this path, because this path has no bearing on how you would align audio. That's for art alignment. So we still do want to make sure that that doesn't actually occur there. So if we come down here and we look at how the rebuild stuff's working, I think that can still work the same way as it was working before. And then what we can do is here I can say, look, let's make an import type audio, and we'll sort of make that be a separate process. And then this again, if is art and, right? So we can do that. And I could change this one to work that way as well. So, you know, I could do if is art and, right? Oops, forgot a little, yeah, there we go. And so that way, again, we can just make sure that these paths that are very specific to art there are only happening when art's actually involved. But otherwise, you can basically leave this routine exactly the same. Now, when we come through here and we do this import stuff, now if we know that the type we're supposed to import is audio, we could do like a process audio import like so, and this would probably take, you know, basically the same stuff. The difference here is like this parse PNG, again, not really going to be what we're talking about, because the PNG would only be for PNG files. So this is an isart kind of a thing. We can leave it that way otherwise. What we really want to then have here is some kind of WAV parse. So effectively what we're going to do is say, all right, we've got a sound 32, you know, who knows what it is. But whatever we want to call our input thing here, you know, and since we called it image 32, I'm just going to say sound S16, I guess, because that's sort of the, well, so it's hard to say. I mean, a sound can have a lot of different formats to it. I'm going to call it sound S16. I think that's the most direct analog. An image U32 is saying, here's an image that uses a U32 as its fundamental sample type, which is an RGBA 8-bit per channel packed format. Sound S16 is saying, look, here's sound. It's going to have its fundamental sample format is a signed 16-bit value. So I'm just going to say that's true. And we're going to do like if it's sound or music in this case, then the sound equals parse WAV. And there's that content stream. And we're just going to leave it at that. I don't really know that we want to do a stream per se. And so what I might suggest, because the PNG likes to read things as a stream, I don't know that WAV really does. I would sort of say that passing the buffer directly might be more straightforward. So we're going to see which one of those two things is true. I'll just say, look, let's see which one's easier to read from. I don't actually know. And so what we can do is see if we actually like the content stream abstraction. If we don't, we can just send down the actual raw buffer. If that's an easier way to parse the WAV, we'll just go with it. So then when we come down here, instead of passing image, we'd just pass the sound. That would be the end of it. This call needs to actually exist. We don't have it yet. Same with the parse WAV call. So those are, you know, two things we're going to have to add. If we look at the parse PNG part of things, that's out in the Handmade PNG. If we want to keep that format alive, that sort of that's the word I'm looking for. If we want to keep that paradigm, there we go. Then what we would want to do here is introduce another source file into that Handmade code directory, which is just called handmade wav.h. And here there would be something like this. I don't remember what these return. Probably nothing would be my guess. Let's take a look there. It is. Yeah, nothing. So this would do the audio import as necessary. It looks like it takes the game assets that it's using to do the import. The match in this case is actually the thing that's produced up here, which is just a way of saying, here is the file that this was coming from. So you can see like it's like a asset source file info there. So I don't know what we want to call that. Maybe like source file, something like this. In this case, sound is one of these imaginary things that we're saying we have. Oh, this doesn't go here. I don't know why I did that there. That's not what goes in there. So that stuff's going to be up in here, right? And so like with the extract image, get down sampling, all this stuff, this is the stuff for images that we're using. And so I'm going to stuff this right here, right there. And this will be just something that we haven't implemented yet. But yeah, like I said, this goes in here. So this is a sound S16 rather. That can just be like that, probably. I don't know how we want to do that. How are we doing it here? Yeah, we just passed the image. So it's a full block. So then inside the temp arena here, this is just going to be our memory arena that we use for temporary allocations if you want it. Here's the process audio import. This is just not, we haven't done it yet. Right? So then what we've got is the parse wav. So in parse wav here, what we want to do, by the way, a lot of people are annoyed that I say parse wav instead of parse wave. I mean, understand the complaint, but let's be honest about spelling. What does that spell? That says wav. That says wave. If this is wave, that can't also be wave. So it's wav, my friends. Parse wav. I don't care what people meant when they made it. They spelled it wav. So anyway, if I'm doing a parse wav to get one of these sounds back, then I just kind of need the the analog of what we were doing before. So we need something here that's going to be one of these sound S16s, and it's going to have basically the same stuff as that image. So it's this, right? Where we'd have a samples array, and probably something in here, like a channel count, where we say how many channels there were, and then you got the samples, and we'll interleave them or something. And maybe the way that we want to do this, I don't actually know, but maybe the way that we want to do this is actually like an array of samples. Maybe there's a max channel count, like maybe we only allow things up to 8 channels or something, and it looks like that. I don't know. We can obviously play with this however we want to play with it going forward, but that's what we're going to do, right? And so we probably want the equivalent of these sorts of things, right? We probably want to have effectively the same calls that we have for our images, just for our sounds. So we would do something like, what's the total sound size? And we get the exact same thing. We know that it's going to be, we know that it's going to be the sound channel count. And we need a sample count as well. We need the sound channel count times the sample count times the size of each individual sample, which is 2, and that's the total footprint of the sound data that's pointed to or pointed into by samples, depending on how we want to do that. I'm going to probably do it this way just to keep it as close as possible to this. That just feels a little bit better to me. So in here, we're going to say sound S16. If we do a push sound, it's the same thing. So we can say, look, give me the sample count, give me the channel count, and I will create that flat footprint for you. So here's the sound S16, that's the result. The sample count is the sample count. The channel count is the channel count. And then when we have the actual samples for our sounds, we're going to do that push size exactly the same as we were doing it before, but we're going to do total sound size in this case for the result, for that sound result that we're giving back. So that's, again, just the exact equivalent. And then we just want the equivalent here as well. We want to say, hey, give us a memory arena to put this thing in, give us a sound return when you're done parsing it, parse a wave file as you would, you can give us some stream information. So you can give us the input and where you want us to send output to if this were a command line, which it isn't. But if you wanted to, we could do that as well. And then we've got the equivalent, right? So now we've got that taken care of. And then in the C file, this is where, okay, don't ask me what just happened there. Okay, there we go. So in the C file now, we've got the implementation of this, which we will do largely by importing code we've already written. But for now, it's not implemented. And the sound.16 result that this comes back, here, that again is just going to return the, pushed version of this that we loaded out of the file. So it's not particularly interesting one way or the other. So that's how our parse wav is going to work there. And I think we can now hop back to the import code. I'm going to build, but I'm going to ignore what it does. That's just to save my files. And so I think we've got things mostly straightened out here the way that I want them to go. I don't see a lot of other stuff. So mostly what we're dealing with is just the head end. When we come through here and we get the file by path and we do this here, this import type, what I want to do there is, I think I just want to stuff that. So I think I want to do like if is sound or is music, do one thing, otherwise try to do it this way, right? And I'm going to set that import type here to like import type sound, or what did I say? Audio. So I need to add import type audio to the list of things that we have defined in the first place. And, public service announcement, you want to actually do that. Not fat fingered there, although I blame the fact that I haven't updated my for coder because that normally would have been the right thing to do. I'm going to add a counter in here too, just in case we want it later. So I'm going to argue that that's structurally more or less what this thing should look like. So that it can just parse inline those particular things. Looking at what we've got here, you can see that we're going to get a bunch of undefined stuff because I didn't include any of this. So what I'm going to do is I'm going to go to handmade.h, and wherever the PNG stuff ends up living, I'm just going to dump wav in there as well, right? So now we can have both of those defined as they normally would be. And we can deal with the errors from that code. So I'm including those, and then I'm going to take a look at what we've got for errors. It looks like that was no errors. All right. So now what should happen is when we actually run this code, hopefully if I did everything right, it'll parse those blocks. It'll decide it needs to do some audio importing, and the audio importing will just roll over and die because all it is a bunch of not implemented code, which is not what we want. So I'm going to start down that route because I just want to dump the code in today. And then tomorrow when we start, we'll start looking at it in the debugger and get it working. So inside our HHA, test asset builder, I think. So if you take a look at this code, which we wrote already, we already did audio importing. Like we did that, right? So what I should be able to do is take this stuff and say, all right, if we've got, a wave importer, let's use it, So I don't remember how I structured the PNG one. Is it in here? Yeah, so I just put it in the header file. I'm going to follow that example. So I'm just going to say, look, here is the wave stuff or WAV stuff, and I'm going to define it thus, right? I don't love the capitalization, so I'm going to uncap that. I know why we did it, but I don't like it. So we're going to call it something else for now. I'm going to just clean this up a little bit. So I'll probably clean this up a little bit, but, over time. So we've got the pragma push pop in there, again, because these are tightly packed, meaning if you take a look at what happens here, occasionally you get something like a hanging uint8. Normally C will pad those structures out for you. Oh, I guess that's not true here. This is a 16. So, honestly, these don't even look like they need the padding. It looks like it's always got a full 32-bit on it, so I don't even know that you would need it. But the pragma pack one here around these is because these are getting loaded from files. We don't want the C compiler inserting any padding. And so it's just to turn it off in case there was a header that had some like hanging data values or interleaved data values that would cause it to insert some padding, and then all of our reads are wrong. So that's all that's happening there. Again, we've done that many times in the past, so I'm just mentioning again. If you aren't familiar with that, you could probably search for that in the Handmade Hero archive and go back and watch the episode where I kind of go over what that means the first time. So if we clean up these a little bit to kind of sort of the more modern version that we're using now, where we've sort of evolved our opinion of this, and now there we go. Just looking at how we're doing this wave chunk ID format, that all looks fine. So this is all fine. Those are the types for the reading. And what I want to do is go take a look at the loading call for the sounds here. So you can see we've got like riff iterator and parse chunk at and next chunk and is valid and all that stuff. Get chunk data, get type, get chunk data size. That's all the stuff for iterating over the riff stuff there. And I don't actually know to what extent we need all of that stuff, but what I will do if we actually do need it is I will go ahead and put those calls into the stream handler. So from now on, we can just use streams as riff iterators and vice versa. I think I'll try it that way first. Because now that we have the notion of an incoming stream that we kind of made for other purposes, we might as well build riff understanding in there in case we want to read riff data types like wave. Again, riff is just, I believe that the IFF moniker comes from the Electronic Arts original IFF, which is the interchange file format. I don't know where the R comes from. Do we have a definition for this? So it is. It's the same it's interchange file format. So resource is the only difference there. I don't know. Let's see. Yeah, so I'm correct. It is based on the original Electronic Arts interchange file format, which is for the Amiga. Yeah, ooh, it even says that right here. Oh, okay. All right. That makes perfect sense. So it says the only difference is that they went Little Endian. So you can understand why, right? The Commodore Amiga was a Motorola processor, so of course it was Big Endian. So it makes perfect sense. So when they did the PC version of it, they changed it to Little Endian so they wouldn't have to constantly byte swap everything. Makes perfect sense. We've talked about Endianness before. If you haven't seen that, again, check the archive. So if we go ahead and import this stuff, you can see that the load WAV call is actually pretty compact. It's much simpler than parse PNG because loading a raw WAV is really simple. It doesn't have any compression in there most of the time. So you can usually just guarantee that you just don't care. So it looks like what we actually did here Well, I'll be completely honest with you, I don't know what we did here. So I'm not sure what the section sample index part of things is. That's what I wasn't sure about. Is that for streaming or was that for something else? So you can see us parse the chunks here. So we get all that out. And then we come down here and say, let's compute, where this chunk's going to go. And then we come through here and we say, if we actually were going to load samples, make sure that the part we're going to load out Yeah, so I think that this was we had baked into the load sort of extracting a section of the song of the whatever the WAV was for streaming purposes. So I'm gonna assume that if I search down for load WAV, that we've got something in here that would actually have done some kind of a segmentation. So you can see the first sample index bit there. So let me see. I just want to make sure I'm right about that before I go changing that around. So no, I don't see. I don't see any sound chaining happening here, though. Let me look and see if there's any reference to actual sound chaining. Aha! So we do load music test, and we do a sound chain on it, and we do, so there's that samplet. Okay. So it's exactly what I thought was going on. Just took me a little bit to verify that that was the case. So effectively what we were doing there is saying, look, when we load the WAV out, we may want to load only a portion of the WAV out because we may want to break it up into chunks for streaming purposes, right? And then the way that that works is we create multiple WAV multiple assets, and we just tie them together with like effectively like a pointer. It's not really a pointer. It's sort of just an ID value that we'd use for chaining. So all we really want to do is make sure we can still do that behavior. I don't really want that baked into the WAV load. I would rather that be handled on the outside. So I think I am going to go ahead and say that the way that I'm going to do this is the parse WAV call will literally parse the whole WAV. And I don't care if that's 2 gigabytes worth of data, get a 64-bit machine, it's not my problem, because this is for asset processing, and I don't want to have to care about it. So then what I want to do is say, anyone who's going to use the streaming chunking breakup, you can do that as a separate work on the loaded WAV buffer, right? So that's my opinion on that, and that's how we're going to do it. Until I hit something that stops me, that's the way we're going to do it. So let's go ahead and see how our stream stuff might handle this. If you take a look at the way it works in here, you can see that you basically consume stuff off of it. And so when we do the parse chunk stuff, what that would normally do is it would consume one riff headers worth of stuff, and then if you wanted to go to the next chunk, it would skip the size of that chunk as it went. So I guess the only thing So I guess, you know, looking at this, what I would say is it does seem like well, I mean, we could still use it just fine. The only thing is, since you're going to want to jump around to various parts of the file, I'm not really sure to what extent we care about that. So it may really not be worth it to integrate it into the stream stuff. I don't know. I don't have a strong opinion about it one way or the other, to be completely honest with you. When we do this parse WAV here, you know, I'm going to just start by playing around with it a little bit, and we'll see what I decide going into it. If I delete this stuff here, then we're ready to start. If I want to get a wave header, the way this would work is I would just say consume, right? And I would say from this stream, And I don't know, yeah, that's going to take an address there. I don't know why we don't pass an address of that. If I look at the PNG reader, what you can kind of see about parse PNG is that it takes a stream by value, which means that it won't change the stream that was passed in. I don't really know why we did it that way. I'll keep it that way for this because we might as well be consistent, but it's a little strange. So I don't really know why we didn't pass in an address of a stream. We must have had some reason. Anyway, if I say consume for the wave header here, so that will come back, and again, just looking back at the stream consume version here, you can see how that shakes out. You say, give me one of the, oops, I didn't mean to point there. Give me one of these, and back comes a pointer to that thing from whatever it was that I consumed it. And that seems fine. In here we say, all right, let's make sure that it's actually what we expect it to be. When we come through here, let's see, we then use the chunk parsing. So that would really just be consuming the chunks and then skipping forward by their size as we go. When we actually want to get the data, you can see that happening here. There's an FMT chunk which tells us stuff like what the sample rate was and how many bits per sample there were. Now, for our purposes, so, well, I didn't finish my almond biscuit. That's how into Git we were. For our purposes, we have an issue with ingested sample rates, and I don't know exactly how we want to solve it. So when we are given a wave file, I think we probably want to just say it has to be 16 bits per sample, and it has to be 48 kilohertz, right? The reason that I think we want to do that is because if we don't do that, we get into a whole issue of how do we want to resample sound that's given to us at formats that we didn't expect, right? There's like a whole can of worms that you open up if you decide to go down the digital signal processing rat hole of how do I take a sound in one format and convert it to another. And by format, of course, I don't mean AIFF versus WAV. What I mean is if the sound was fundamentally recorded at one sample rate, 48,000 samples per second, 44,000 samples per second, whatever it was, and you want it at a different sample rate, which in our case will always be 48,000 samples per second, but whatever it is that you happen to want. Transitioning between those two sample rates is not a direct conversion. You have to actually apply some kind of signal processing because you fundamentally have a single signal that you don't know what it is. You have no idea what the original signal was. And all you have is sample points spaced out at a certain distance. And now you want to know what that signal, you don't know what it was, what it would have been, what the samples would have been if they were spaced differently, right? Fundamentally, the answer is you can't, right? There is no way to actually know the answer. Because without knowing the original signal, you have no idea what it would be sampled in different locations. But much like images get resized and they still look like themselves, the same is true for sounds. But exactly analogous to images, what kind of filtering you choose to do to produce a different size or a different sampling of the original thing has artifact effects. There are things that will actually occur, right, that will be better or worse quality or have different concerns in terms of what ends up happening to the frequencies you hear in the sound and how they are reproduced, based specifically on how you choose to resample. Now, fortunately, just straight linear interpolation actually works remarkably well to the untrained ear. But suffice to say, if you really want to know what's going on and tackle that problem directly, you kind of want to know more digital signal processing, or DSP. And so, again, it opens up kind of a whole can of worms that I really don't necessarily want to open. What I would rather do is say that anyone who wants to put sounds into Handmade Hero should open up a program that has good DSP, right? A good sound editor, maybe Reaper, and resample there, right? Like resample in a package where you have some control over it, where someone hopefully did some DSP work to ensure that you were going to get good results, and only give us files that are actually sampled at the right sample rate. So I think we probably want to change these asserts so that they're not asserts, they're just errors now. But we do still probably want to error. I don't want to try and handle multiple formats. Now, we're basically out of time, so I think what I'm going to do for now is I'm going to if zero this app block out. Like so. And then just clean up any compilers we have. We don't have any. I'm going to leave it there. And then tomorrow we will try to get audio import started. All right. So let's go ahead and go to Q&A. Will C++ add CSV type concurrency in the next edition? So one thing that hopefully everybody knows about me is I do not follow the C++ specification. So basically, not only do I not know what they will add in the next edition, but I don't care what they will add in the next edition because it's always terrible. So, you know, will C++ add hermeneutic graph traversal to the next edition? Not only do I not know what hermeneutic graph traversal is, but I can guarantee you that when I actually do need to know what it is and I go learn about it, I will find that the C++ standard committee's version of it is terrible. Because that's literally what always happens. Like, pick a language feature. The day you need to use that feature, if you go look at C++'s version of it, it sucks. That they added the worst possible version. Like, they almost like, it's like they started a committee to try and figure out how to make sure that they would only add a version of that thing that was lousy. And I don't know how they do it. They do it over and over. It's like they've got like some kind of a master's degree or like a PhD in never doing the best version of something. They're like, let's come in fourth on everything. In fact, that C++, there is a language called fourth. C++ should actually be called fourth. Because if you were to rank the languages at how well they implemented a particular feature, like C++ would always come in like fourth. At best. Have you seen Brett Victor's talk, Inventing on Principle? I have not. On the pre-stream, I had asked about finding the filter kernels, and you asked whether I meant the integer or the floating point. Do you mind explaining how you found each? Thanks. Sure. So the integer filter was found by literal just trial and error. There are so few possible filters that are close to a sharpening filter in integer in divide by 32, which is what I was working on. I ideally wanted to find divide by 16. I couldn't find one good enough. So then I went to divide by 32, that you can basically just try them all. There's just not very many, right? Because each coefficient fundamentally can only be between 1 and 15 over 16, and they have to add to 1, and they have to look like a sharpening filter, so they have to pretty much look like a sync, sort of, like something sync-ish. And so there were only, I don't know, 20, 30 candidates. I mean, it was so few that I just looked at them and picked the best one. Floating point, I didn't do that. I just cheesed out on floating point. I just said, look, here's an ideal filter, quote unquote. Here's one that I know is infinite, and let me just search in between them. Was all I did. You can do other things. You can use eigenanalysis on them, which I was told by Fabian you can just do in Octave. Octave just has this built in. It's like one call. To look at the eigenvalues, but even that doesn't really quite get you where you want to be, because it's hard to know where you want those eigenvalues to sum to 1, sort of, but because truncation is in the mix, you can actually push harder than that and have them sum to something slightly over 1, and that's actually usually the best filter. So it's still a little bit of a trial and error process. You know what I'm saying? Have you tried Oni? No. Is that a language? Modern modal editing powered by NeoVim. So it's an editor. No, I have not. I have not tried that. So, yeah, I mean, just looking at it, it doesn't look like something that would interest me particularly. So I doubt it would be something I would be interested in, but, it's hard to say without actually using it, obviously. Oops, that's the wrong computer. There we go. Do we want 32-bit floating point samples for high-quality audio streams? No. I don't think so. I mean, I'm not really an audiophile. I'll start with that. But I guess what I would say is I don't really know of much in the way of audio sources where you would need 32-bit floating point audio samples. Like, what sound would you be recording that would require 32-bit float as the storage format? Obviously, we mix in 32-bit float because it's just fast, right? Modern computers are very fast at 32-bit float mixing, so you might as well, and you don't have to worry about overflows or things like that in the middle. But I mean, I'll start with the fact that just I already licensed music for Handmade here. Where we license music from only delivers 16-bit audio for the music in the first place. So our music obviously wouldn't be a 16-bit. Wouldn't be a 32-bit floating point source. For sound effects, I haven't really done anything for that, but we would probably also contract with someone for sound effects at some point. Would they deliver us 32-bit float sound effects sources? I don't know. Maybe people do that nowadays. I don't know. I'm not, like I said, I'm not really an audiophile, so I don't know, but I just don't. I don't really know of any reason for that. I mean, I guess what I would say is, what is the sound that you think that you need 32-bit floating point recording for as the storage format? Like, is there? Can you name a circumstance where you can actually tell the difference between those two? Like a normal human being, like not a dog. What do you think about procedural audio? I think it's interesting, but we won't be doing it on Handmade Hero. Why was the Windows sync worse than the one you found? If syncs are ideal, does the kernel need slight changes from the ideal's values once it is windowed? So I guess I don't know necessarily that I can say why per se. I assume it's because the way that the sync is windowed constructs something whose eigenvalues are actually higher than 1, but I don't really know. Fabian probably did the analysis. I'd have to go back and look. He sent me some mails. I asked him to please post the stuff he sent me to his blog. I never heard back from him on that. My guess is he just doesn't have time to do that, right? It takes time to put up a blog post. He, I want to say, did that. It's either he or Charles did that, and probably had the answer in one of those emails. But that was a private communication, so I can't point you to that. Is it possible to write a graphic card debugger like Nsight, or is it something that has to be done by graphic card vendors? My assumption would be like yes and no. Graphic card have only the vendor can provide the low-level access necessary to do debugging features. But my limited understanding of the way that they work right now is that those features are not hidden. So I think once you install the debug version of the drivers that Nsight uses, I think you can also ask for that information. Like the performance counters and the, debug information that they're getting. I think you can get it. Don't quote me on that. But my understanding was that, while you do need debug support in the driver, because obviously that's the thing that can actually talk to the graphics card and figure anything out, getting access to those pieces of information that you wouldn't necessarily already have, I think you can do. I think you can do that on, as long as you're on one of those debug drivers already. I'm a computer science student, but recently started following your series on YouTube. It helped me a lot because you explain really good in depth. I just want to say thanks for all the work you do for us, and I hope that I never catch up with the series because you will never stop doing them. Well, thanks for the kind words. You'll catch up someday. Well, here's the thing. Either you'll catch up to the series someday, or you'll just be good enough that you don't bother watching anymore because you already know, right? You'll get one of those two places. Anyone who doesn't give up on the Handmade Hero series pretty much will get to one of those two places. Either they catch up someday, or they just get so good that they don't really need me, right? They don't need me telling them what to do anymore, right? They graduate. So something will happen if you keep at it. That seems to be the case. I'm still wondering why we chose Git over Travel Man despite its simplicity. I'm just not convinced it's better. I don't know that anyone did choose Git over Travel Man. What happened was, since Alan keeps his source code on Git anyway, He just gave me access to Git, thinking that would make it easier for us to share information. As you saw during Furcoder Jam, that is not what it did. Travelman is way better. But, Git, ladies and gentlemen, source code control that's actually slower than the copy command. No more questions? You know what I should do too? I posted this on Twitter. I should add it to our builds. You'll notice that like when you get error messages in Visual Studio, I posted this to Twitter just because I didn't know about this. I went and was looking. I was like, they must have added it by now, and I went and looked, and it turns out they had. It's just kind of a little bit buried. When you get error messages, you don't get column numbers. You just get line numbers. And I always was kind of sad about that. But what I realized was that there actually is one that they added, I think in 2017 or something. So if you actually add minus diagnostics column, I think, if you add that to your build line, it actually tells you where the errors are by column. Oops, I should put the error back in. It actually tells you where the column is of the error as well, right? So you can see it got that. And so when like in the editor now, right, like Furcoder can jump right to the token that was wrong, which is kind of nice because if you have something like, result sample count equals sample count, or just, 5 plus 3 like this, and then you do builds, it's nice if you can just say jump right to the error. So, like if this line was long, I'm trying to give a good example. Right? So, I do some build and I've got some big long line with tons of stuff in it. I know that's not a very good example, but imagine there's tons of confusing stuff in it. And you're like, where is the actual, like, error? Now it'll go right to it, right? Because it knows the comments. So I don't know how many editors support columnar errors, but I suspect many do. Furcoder does. Other editors probably do. Because a lot of them work with Clang, which supplies column numbers in addition to line numbers. So just public service announcement, add diagnostics column into your build line. It's just a free, nice, time-saving thing. It can only help, right? As long as your editor supports it. If your editor doesn't support it, maybe it will confuse your editor, in which case, not so good. But other than that. JBC Gannon, you made an offhand comment on source code control tool you made for yourself. I take it if you have seen it other than yourself. Actually, yes. Technically, nobody has ever seen it but me. Well, I guess Anna's seen it running. But Edge Jorb, they intentionally didn't make reporting columns default behavior in order to not break back to LE. Exactly, yeah. There are probably editors that just don't know what to do with a line of that format. And so I'm sure that Visual Studio couldn't just start reporting columns because it would just break everybody. So they put it under a switch and then didn't really publicize it particularly well. So, nobody knew about it. But it's there. So as long as it doesn't break something that you have, it's great, right? Turn it on. Have you seen VLang? Is it vaporware? I think I saw somebody mention it. It was like a language being made for an email client. No, like a social media client or something. I don't even know. A messenger client or something. I didn't look at it at all, really. No. So is it vaporware? Who knows? I have no idea. I don't know anything about it. I've read the sequel said, since there are so few questions, can I just comment that your coding style is super pleasing? Just popping out structs left and right, so procedural, no weird specificisms, verbose, variable, and function names, so there's no ambiguity. It's nice and has a huge influence on my style for the better. I'm very glad to hear that. I really can't emphasize enough that, like, code being clear and procedural is incredibly important. It's important in way more ways than people realize. Legibility is obviously one of them. Maintainability is another one. But also just efficiency. Like code that's written roughly like the CPU will actually do it is just a really good way to make sure you're not making something super piggy and bloated that just runs really slowly. I like high-level language features, actually. I know it probably looks like I don't. I actually do like high-level language features. The problem is that C++'s high-level language features are just all terrible. All they do is make complicated, weird, convoluted code that sucks. Like, it's not good high level. It doesn't let you make good code quickly. It lets you make bad code quickly. And that is not what I want out of a high-level language feature, right? So I would like to say that I don't really like the fact that I don't get any high-level language features when I program in C++ because the only ones available to me are lousy. But I would like some eventually. So it's not that I don't think I think high-level language features are good. I wish they were geared towards things that I care about and written in a way that I like. They're often not, so I can't use them in C++. But barring that, even when I have high-level language features, I still prefer it to be in a procedural mode. So I still like to be able to see what is happening correctly laid out. And a lot of high-level languages don't do that. They just are totally convoluted, and trying to figure out what's actually going on under the hood takes a long time if you didn't write the code yourself. And I don't like that. So I like it when high-level is still clear. And I think you can do that. I just don't think languages prioritize legibility and efficiency when they're doing high-level languages. They tend to prioritize weird, like, they get into these weird, like, headspaces where they're not thinking about the CPU. It's like they're in completely abstract land. And that I just don't find productive. It leads to bad decision making, and it leads to high-level programming languages that can't produce good code, right? Hit a wall. Every company I look up demand OOP and not a healthy balance of procedural, but the ultra radical OO and nothing but OO. Yeah, I mean, you know, what can you do, right? There's a reason you get paid to program, and it's because it's not always fun. And having to use object-oriented programming is one of those ways it can be really not fun. Enthusiast, at work, I started rewriting a Python package in C. Its performance is so bad that nobody wants it anymore. I was wondering why people do not write in native code that often anymore and choose the scripting languages that cause a lot of people problems further down the road. Do you have any comment on that? Yeah. They just think it's too hard, right? Writing in native code, once you're kind of in package land, where you think like, oh, I'll just install these 17 Python packages, and then it'll only be a few lines of code to do this thing, you know, that helps you get stuff done quickly that you don't understand. Right? That you couldn't have written yourself, or that would have taken you too long to write yourself, or whatever, right? And there's some benefits to that, which is to say that you can write something that you don't understand, or you can write something that would have taken several months, and you could write it very quickly. Problem is, it sucks, right? It's really slow, and it's probably very buggy, and it probably has a lot of hidden problems with it you don't know about, because you have no idea what those 1,100 packages are doing, right? And so it's just a bad trade-off that people get themselves into, right? And, you know, what can you do, right? We haven't gotten to the silver bullet yet where you can write a few simple things and get really great code out the other end. We aren't there yet, right? And I don't, maybe we'll never be there, but, you know, assuming that someday we get there, it's further down the line, and, you know. All right, I think I'm gonna end it there because we are out of time. I don't see any other questions that are like on what we were doing. So you know, I try to answer any questions that are on what we actually did. But you know, off-topic stuff I'm okay with just kind of skipping for now. We can always tackle them another day. All right. I don't know if I made any changes, but I'm gonna save anyway. Here we go. All right, thank you everyone for joining me for an episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along with the series at home, you can always go to handmadehero.org, and if you pre-order the game, it comes with the source code right now. So you can play around with it, play around with what we're doing, learn from it, whatever you want to do to sort of follow on the series at that point. It makes it pretty easy. I'll be back here tomorrow, same time, same place, to see if we can get that WAV parser actually integrated in. Shouldn't be too hard because we already have a working version, but we got to do the massaging, and then we have to get it integrated in the asset system properly as well, so when it actually does its import, those assets will be placed into the asset system in a logical way, which again requires a little bit of work because we kind of redid the way we did some of our memory paging and stuff like that. That's about it. Hope to see you back here for the next stream tomorrow. Until then, have fun programming, everyone, and I'll see you on the internet. Take it easy, everybody.